Have you ever wondered how a tiny signal from a controller can turn on something that needs much more power? How can a small microcontroller control a motor, lamp, solenoid, or even another high-power device? The answer is a relay.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
In robotics and automation, a relay acts like an electrically controlled switch. It allows a low-power control circuit to switch a higher power load. Today, let's learn what a relay is, how it works, the different types of relays, and why they're useful in robotics. What is a relay? A relay is an electrically operated switch. Instead of pressing the switch with your finger, an electrical signal controls it. A typical relay has two main sides. The control side receives the electrical signal. The load side switches the power going to the device. Think of it this way: small signal, relay, bigger load. For example, a microcontroller might send a small control signal to a relay, and the relay can switch a motor, lamp, pump, or solenoid. How does a relay work? Inside a traditional electromechanical relay is a coil and a set of contacts. When current flows through the coil, it creates a magnetic field. That magnetic field moves a small mechanical armature. The armature changes the position of the contacts, allowing current to flow or stopping it from the load. So the basic process is electrical signal, magnetic field, mechanical movement, switching. And that's the magic of a relay. Types of relays. Now that we know how a relay works, let's look at some common types. There are several ways to classify relays, but for robotics, these are the most useful ones to remember. 1. Electromechanical relay. The electromechanical relay, or EMR, is the classic type of relay. It uses a coil, magnetic field, and mechanical contacts. When the coil is energized, the contacts physically move. You can actually hear a small click when it switches. These relays are commonly used in control circuits, robotics, industrial automation, automotive systems. Simple idea: electricity creates magnetism, magnetism creates movement, movement switches the circuit. 2. Solid-state relay. Next is the solid-state relay, or SSR. Unlike an electromechanical relay, it has no moving mechanical contacts. Instead, it uses electronic components to perform the switching. Because there are no moving parts, solid-state relays can switch quickly and operate quietly. They are useful in applications where frequent or fast switching is needed. So remember, electromechanical relay equals mechanical movement. Solid-state relay, electronic switching. 3. Reed relay. Another type is the reed relay. It uses a small sealed contact called a reed switch, which is operated by a magnetic field. Because of its small size and ability to provide electrical isolation, reed relays are useful in certain sensing and control applications. They can be found in instrumentation, security systems, sensors, test equipment. Latching relay. A latching relay is interesting because it can maintain its switched state even after the control signal is removed. In other words, it can stay on or off without continuously powering the coil. Some latching relays use one coil, while others use two coils to change between states. This can help reduce power consumption in certain applications. Think of it as, I don't need you to keep pushing me. Once I change state, I'll remember it. 5. Time delay relay. A time delay relay doesn't switch immediately. Instead, it changes state after a specified delay. For example, a controller sends a signal, the relay waits for 5 seconds. Then it activates the load. This type is useful for sequencing, motor control, industrial automation, timing applications. So the idea is simple: signal, wait, switch. 6. Overload relay. An overload relay is commonly used to protect motors from excessive current. If a motor draws too much current for too long, the overload relay can cause the motor circuit to disconnect. This helps protect the motor from damage. However, remember that an overload relay is primarily a protection device, not simply a general-purpose switching relay. Relay contacts: nitrogen monoxide, NC, and COM. Now let's return to the relay contacts. You may encounter 3 common terminals: COM, common; nitrogen monoxide, normally open; NC, normally closed. When the relay is not activated, TOM, NC. When the relay is activated, gain nitrogen monoxide. So, normally open, The circuit is normally off and turns on when activated. Normally closed. The circuit is normally on and turns off when activated. This gives engineers flexibility when designing control systems. Relays in robotics. Relays can be useful when a robot needs to control devices that require more power than the controller can provide directly. For example, imagine a robot with a microcontroller. The microcontroller detects a condition using a sensor. It sends a signal to the relay. The relay switches the power to a motor, lamp, pump, or solenoid. So we have sensor, controller, relay, load. The relay becomes the bridge between the control system and the electrical load. Relay versus ordinary switch. So what's the difference between a relay and an ordinary switch? An ordinary switch usually requires physical movement. A relay can be controlled electrically. You don't have to physically touch it. That's why relays are useful in automation systems. A controller can make switching decisions automatically. Relay versus transistor. You might also ask, if we already have transistors, why use relays? Good question. Relays can provide electrical isolation between the control circuit and the switched circuit when properly configured. They can also switch certain AC or DC loads depending on their specifications. However, relays are mechanical devices. They are generally slower and have moving parts that can wear out. Transistors can switch much faster and have no mechanical contacts. So the choice depends on the application. Important safety reminder. Here's something very important. Never assume a relay makes a circuit automatically safe. The relay must be properly rated for the voltage, current, and type of load being switched. High-voltage AC circuits can cause serious injury or fire. For classroom robotics, start with low-voltage DC circuits and use properly rated relay modules. Safety first before experimentation. Simple robotics example. Imagine a robot designed to automatically turn on a small water pump. The sensor detects that the water level is low. The controller processes the sensor signal. The controller activates the relay. The relay closes its contacts. Power flows to the pump. The pump turns on. When the water reaches the desired level, the controller deactivates the relay. The relay opens the circuit. The pump turns off. That's automation. Hugot moment. A relay is like a friend who connects two people who couldn't directly connect. Hindi man ako ang source ng power. Ako naman ang nagkokonekta para umandar ang kailangan mong paandarin. And sometimes in life, hindi lahat ng malakas ay kailangang ikaw mismo ang gumawa. Minsan, kailangan mo lang maging relay. Ikonekta ang tamang tao sa tamang oras para may magandang mangyari. Why are relays important? Relays are important because they allow control systems to switch electrical loads using a control signal. They are commonly found in robotics, industrial automation, automotive systems, home automation, control panels, electrical equipment. They give a controller the ability to command circuits beyond its own direct output capability when the relay and power system are properly designed and rated. Quick recall. Let's remember the lesson with a simple sequence. Relay equals electrically controlled switch. Coil creates the magnetic field. Contacts switch the load. Controller sends the command. And remember the major relay types: electromechanical, mechanical contacts, solid state, electronic switching, read, magnetic read contacts, latching, remembers its state, time delay, switches after a delay, overload, helps protect motors. So when you hear the word relay, remember, small control signal, big switching job. A relay may look like a simple component, but it plays an important role in automation. It allows a control system to command another electrical circuit. And that's one of the important ideas in robotics. The controller doesn't always have to do the heavy work. Sometimes, it just needs the right component to help it. Because in robotics, hindi kailangang ikaw ang may pinakamalaking power para magkaroon ng malaking impact. Minsan, kailangan mo lang marunong kumonekta. And that is the power of a relay.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.